So I wrote this script because I wanted to demonstrate the amazing things you could do with Python functions and really functions in any language. So here's one definition of a function. I call it square one because I'm gonna define more than one square function. But this is what we wrote before. Okay, so for I in range 4, which means this is going to loop 4 times, turtle.forward 100, and then turtle.left 90. Okay, hopefully you'll understand my incorrect hand gestures there. I imported turtle at the top. And then I ran these couple of commands down here. Speed 9 sets it to 9 out of 10 for speed, so it's going to execute really quickly. And then turtle.home is what we've been doing. And notice that when I hit run, it's going to run all of these things in order. So that's much faster than me typing each one and hitting enter like we would do on a REPL. But notice that it doesn't draw my square, even though this has been defined. If I were to do, import, blah, 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 pp and then pp globals, that it would show that square one has been defined. But in order for this code to actually run, I've got to call the square one function like that, like we would normally do with a function. A couple of other things to note here. Every line that starts with a pound sign is a comment. Okay, comments are going to be an amazing feature when you write scripts because you can see here, this tells you, the reader, or another programmer I'm working with, what this function is supposed to do and a little bit of details about it. Okay, so functions are really, really important. They help your code be more readable. And if you remember, import this. Hopefully this works here. Oops. Yeah, import this. Readability counts is one of the main points of Python and really any programming environment. So I'm running square one right here, which is just any kind of one particular kind of square, which is 100 length. Okay, if I tried to change the length, it would not work because it says this function, square one, takes exactly 0 arguments. It can only be run without arguments. Now I've got another version of this called square 2. I'm going to cut that and don't look ahead to square 3 just yet. And when I paste it in REPL, it's so awesome. It maintains its formatting. Because remember, these tabs are really, really important. Oh, another cool thing about REPL is that you could see these tabs with little lines here. That's nice. So square 2 takes in a variable size, and then it puts the size there as well. So I think we demonstrated that. So let me change this to square 2 and try to run square 250, and it'll actually work. And if I wanted to do some cool things, like, I don't know, 10 of these, and then I'm going to use this I here. I'm going to do I times 10. See what that does. So it's making 10 of these squares. It's calling the square 2 function 10 times, and each time it changes. So the very first one is actually 0. That was a waste. And then the next one will be 1, so that'll be size 10, then size 20, and size 30, etc. So the next one is going to be square 3, my square 3 function. And geez, I can't see this. Here we go. Let me put square 3 in here. Like I said before, you don't usually want to repeat yourself, but I am just demonstrating the different kinds of functions we can have here. So this is pretty cool. This is called a default value for this parameter. Okay, so I said size equals 100. So when I do, let me get rid of this for loop here. When I do square 3 by itself, it will not get mad at me, even though I have a parameter in here which is called size, and that's because square 3 has this parameter size, but there's a default value to it. It's going to be 100 if you don't specify anything else. Now, if you do specify something else, let me do something more clear, like 10, then it will run size. It will run with size being equal to 10. But if you do nothing in there, then size, it knows that size is going to be 100. That's what you set it as for the default. Okay. Let me show you another one. This is square, oops, I skipped 4. Here's square 4. Let me paste that in here. There's a lot of white space, too much white space. Okay, so square 4, I added 2 parameters. When you add 2 parameters to a function, you have to separate them by a comma. And same thing down here when you call them. When you call the function, you have to specify that parameter and then specify this parameter. I'm going to do blue here, okay? And then blue, I told you, is a string. So, oops, I'm still using, get out of here. I'm still using square 3, so let me try to use square 4. There we go, a blue square of that size, and I could change that size. And if you leave either of these off, it's going to get mad at you. And if you switch the order, it'll get mad at you. It takes 2 arguments, and then if I try blue, didn't quite work. And the reason it didn't work is because it thinks that blue is equal to size, and it thinks that 50 is equal to color. So whenever I say turtle.color, excuse me, right here, turtle.color color, it places 50 in there, and that kind of doesn't really work there. Same thing with size. It says forward blue. That's not really a size. It interestingly didn't give me an error, but it's still thinking that this is the size and this is the color. Now, I can override that by doing what's called a keyword argument. So right now, these two are positional arguments, meaning that they're in this position, in this order, because this is the first one and that's the second one. And it matches up with the definition here, or it's supposed to. But what I could do is name these and say color equals blue and size equals 50. And I can do this in any order when I do these keyword arguments. But let's run that. And there you go. There's my 50, size 50 square. That's blue. This is bad practice, though. Don't do this. Don't switch up the order of the arguments. You're just going to confuse people because they're going to look at the docs. They're going to look at the documentation of this function and see, okay, there's supposed to be size and then color. Why in the world did you do color and then size? So if you want to be clear in your code, use these keyword arguments. Put the name of the variable and then equals and then the value of the variable, and there's nothing wrong with that. It makes it a little bit longer, but it definitely makes it easier to read, and it kind of is self-documenting. A lot of people say you've got to add comments, to everything, but Python is really nice about self-documenting. The code itself is like the comments. It tells you what's going on. You know, this number here is the size, and this value, this string here is the color. Of course, like I said, you don't have to do that. You could do that only when it's a little confusing or whatever. Oops, non-keyword arg after keyword arg. That I did forget. The only stipulation there is if you were to do keyword args, they all have to be after. So if you were to name these arguments, they have to be after the arguments that are not named. Okay, so that is kind of weird. Let's go to my fifth square function. Beep. Let's cut this. Beep. Put it in there. All right, so square 5 does sort of the same thing, but this one is a default value. It has a default value. So if you leave that one off and just put in the size there, I'm still calling square 4. There we go. Square 5. If I leave the color off, it's going to default to this black. And in my definition, I could change that to blue if I wanted to. So the default value is blue. But then again, you can rename it. So you could reassign that value. So I can make it red. I could say color equals red just to be extra clear there. And that's the same thing. Okay, so there are lots of ways to use parameters in your function definitions and in your function calls. But remember, order matters, and you have to put keyword or named arguments after these positional arguments.